This is part 2 of the homework video guide for section 1.6, and for this homework video guide I'll be starting off with question 4a, and I need to simplify 2 root 9. Okay, so for this problem I recognize there's a perfect square there, so root 9 is going to be 3, and then this 2 can just tag along on the outside, and 2 times 3 will be 6, so 6 is your final answer for that one. For letter B, I have a perfect square right there, and the square root of 25 is going to be 5, and then the 4 is just tagging along on the outside, so 4 times 5 is going to be 20. For letter C here, I will approach this using 2 different methods. So I have root 40 there, so I will write a 6 on the outside, and I will try my best to write root 40 using a perfect square. So I'm thinking of 4 times 10, so 4 times 10 is definitely going to be equal to 40. And one of the reasons why I used 4 times 10 is because then I can break this up into 2 individual radicals. So this would be 6 times root 4 times root 10. And there you go, here's my perfect square right there, root 4. So now I have 6 times, well, the square root of 4 is going to be 2, and then the root 10 just remains as root 10. And then if I multiply 6 times 2, I get 12. So 12 times root 10 is my final answer for letter C. Okay, I will try this problem using a second method because some students don't like the perfect square method. So I can instead I'll try a tree diagram. So some students prefer using a tree diagram instead. So find 2 numbers that multiply to 40. I'll just use 2 and 20. Alright, so this 2 is a prime number, so I can stop there. 20 I can break down into 2 and 10. So this is a prime number, so I can stop there. And then I have 2 and 5. And I have prime numbers here and here, so I can stop with the tree diagram. And after that, you want to find groups of 2. So here's a group of 2 there. So that will combine as a single 2 on the outside. Then you have a square root, and then basically these 2 numbers, the 2 and the 5, will go on the inside as 2 times 5, and 2 times 5 is going to be 10. So that's going to be 10. And then finally, there is a 6 on the outside here, so 6 times 2 is going to be 12, and the final answer is 12 root 10. So you will still get the same answer, but some students prefer the tree diagram method, so I will use the tree diagram method as a solution as well. Okay, let's move on to letter D. Okay, so I see root 8. So I'll try to break that down using a perfect square. So I'm thinking of the numbers, 2 numbers that multiply to 8, where one of them might be a perfect square. So I'm thinking of 4 times 2. So 4 times 2 is 8. And then I can break this down into 2 individual radicals. So this will be root 4 times root 2. And there it is. The square root of 4 is a perfect square, so that's going to be 2. And then the 3 will be on the outside, and the root 2 will remain. And finally, 3 times 2 is going to be 6, so 6 root 2 is my final answer for letter D. Okay, and I'll just do this problem one more method, using method number 2, which is the tree diagram method. So 2 numbers that multiply to 8, I'm thinking of 2 and 4. So this is a prime number, I can stop there, and 4 breaks down into 2 and 2, and these are prime numbers, so I can stop. Here's a group of 2, so that goes on the outside as a single 2. And this single 2 that doesn't have a pair, that can go back in the inside. So 2 root 2 is your final, that's how you break down root 8. And then recognize that there's a 3 here, and 3 times 2 is going to be 6. So 6 root 2 is your final answer using the second method. Okay, so use any method that you prefer. I'll show both methods in my video. For letter E, I have 4 times root 27. So root 27, so think of 2 numbers that multiply to root 27 where you could create a perfect square. So I'm thinking of 9 times 3. And then after that, you can break this up into 2 individual radicals. So this will be 4 times root 9 times root 3. And root 9 is going to be 3, right? So 4 times 3 times root 3. And then you recognize that 4 times 3 is going to be 12. So 12 times root 3. So 12 root 3 is your final answer. That's using the first method. And then I will solve this problem using the second method here. So 2 numbers that multiply to 27, that's 3 and 9. So 3 is a prime, so I can stop. And then this 9 I can break down into 3 and 3. and then I can stop there because those are prime numbers. And let's find a group of 3. So here's my group there, or a pair there. So that will be on the outside as a single 3. And since this 3 has no pair, I can move this into the inside as 3 root 3. And then 4 times 3 is going to be 12. So 12 root 3 as a final answer there. Okay, so let's move on to the next one here. Letter G. So letter G, this is a good one here because I have a negative fraction. Sorry, I have a negative fraction on the outside here. Okay, so let's deal with the radical again. So think of 2 numbers that multiply to 32 where you can create a perfect square. So maybe 16 times 2. 16 times 2 is 32, and then you also have this negative 5 over 2 on the outside. Okay, and then the next step would be negative 5 over 2, and then I can split up these into 2 individual radicals. So this will be root 16 times root 2, and there you go. Here's my perfect perfect square root there. So the square root of 16 is going to be, the square root of 16 is going to be 4 times root 2, and I also have this negative 5 over 2. Okay, and then we just got to simplify this. A few ways you can do this. I like to do division first if possible. So what's 4 divided by 2? Well, 4 divided by 2 is 2, and 2 times 5 is going to be 10. So negative 10 root 2 as a final answer there. Okay, let me just erase this, and although that's the answer for method number 1, let me just show you how you can do this using a tree diagram now. So this is method number 2. If you are good with method number 1, you can definitely move on, but I'll do method number 2 over here. So the square root of 32, I can break that down using a tree diagram. So 2 numbers that multiply to 32, I'll use 4 and 8, and 4 can break down into 2 and 2, and these are prime numbers, so I can stop. And then I have an 8, so I'm thinking of 2 and 4, and 2 is a prime number there, and 4 can be 2 times 2, and these are prime numbers there, so I can stop. Okay, so from there on, you need to find groups of 2. So there's a 2, and there's a 2. So this pair comes out as a single 2 there. This pair comes out as a single 2 there. And then I have a radical sign, and this 2, this 2 here will go on the inside as a single 2. And erase all that. And then we have 2 times 2, which is going to be 4. So 4 root 2. And then remember, we still have this negative 5 over 2. So negative 5 over 2. All right, and then we kind of get back into the same situation here. I'll just do this for now. What's 5 times 4? 5 times 4 is 20, and 20 divided by 2 is 10, so negative 10 root 2 is a final answer there. So regardless of what method you use, you will still get the same answer of negative 10 root 2. Okay, let's move